Okay, so hello and welcome to the Python basics training video. Today I'm just going to be showing you the basics of Python, the syntax, how to define variables, etc., etc. So let's get started. I'm working on a Mac machine. If you're working on a Linux machine, it's going to be very similar commands. On Windows, it'll be slightly different, but once you have Python opened in your shell, it should be fine. Okay. So on a Unix system, the way that you open up the Python programming language in the interpreter is you simply type in Python. Now doing this will start up the default version of Python you have installed. On my system it defaults to Python 2. Python 2 is not the most recent though. So if you type in Python 3, it'll automatically open up the most recent version of Python 3 you have installed, and that's what we'll be using for the tutorial. There are slight syntactic differences between Python 2 and 3, slight differences in how certain arguments are handled, etc. The reason we're going to be using Python 3 is because nowadays it's the more commonly used one, and any commands that you write in Python 3 can be used in Python 2, but not vice versa. So by learning all the Python 3 commands and syntax, you'll be able to use Python 2 as well if you need it. Okay, so we'll start simply. If you've ever used an interpreted programming language before, you've seen something like this. Similar to a language like R, you could type in commands like 1 plus 1, or 1 plus 2, and it'll spit out an answer for you. To do something a little bit better and define a variable, we'll say x equals 1, and this assigns the value 1 to x. We can increment x by 1 by doing something like x equals x plus 1, or equivalently x plus equals 1. And that saves a little bit of code typing. Next we'll do loops. So we'll start with a simple while loop. We'll reset x to 0, and we'll say while x is greater than or less than 10, we'll print x. So this is the print command. This is how Python will print a line onto your command interface. So in Python 2 you don't need the parentheses, in Python 3 you do. As I said, the parentheses will work in Python 2 as well, so we'll stick with the parentheses. And then we'll increment x by 1. So we get the numbers from 1 through 9. One note that I should make is that in Python, the way that loops are stored, and you'll see the same thing with functions and classes when we get to those, is through a system of colons and indentations. So to start an indentation system for something like a while loop or a for loop or a class definition, you have a colon, and then after the colon you have either as many spaces as you decide to define or a tab. This is not a time for a tab versus space discussion, but both work. So yeah, all code that's part of the while loop has to be indented to be part of it. Okay, now we'll get to for loops as well. So all of this code could be written in 2 lines instead of 3 with a for loop. So a for loop takes in an iterable object like a list or a tuple or a dictionary. We'll get to those. In this first example, our iterable object will be a range. So a range object, like a range 10, that gives you a range object, which is iterable. To print it out nicer, we'll make it into a list. So here you have every item in the range iterable, and you have essentially starting from 0 and going up to the number, up to but not including the number specified in the range command. You could also do something like range 5, 20, say. And that starts at this number and goes up to but not including this number, traversing by integers. you could also do range, let's say 0, 10, 2. This increments by the third argument, so you get all the even numbers up to 10. The reason that I'm using this list command right now is to make it easier to see on the terminal screen, but when we use a for loop, like I said, the range object is iterable, so we can iterate straight through it with a for loop. So the syntax for a for loop in Python is for, and then you create a new variable name as you iterate, so we'll call it I, is the most standard, in, and then you have your iterable object here. So here we'll do range 10. Okay, we put in our colon, we indent, because that's how we specify the contents of the for loop in Python, and we do print I. Okay, and now that we stop the indentation, Python interpreter knows that we're done defining our for loop and it executes it. And here we have the same numbers, 0 to 9, as we did with this while loop. Okay. So the range object is useful, but a lot more commonly used data structures are things like lists, dictionaries, tuples, which if you are familiar with other languages, you'll be very familiar with as you see them. So we'll start with the list. So you can define a list in two ways. You could either have two brackets like this, and that gives me an empty list, or you can use the list command. Same thing. So let's create a variable called lst equals a new list, and I'll show you some useful methods for lists. So first we need to add some numbers to our list lst. So why don't we kind of use our for loop knowledge to do that. So we'll do for I in range 0, 22, so they'll all be even numbers. And then we'll do lst.append I. So what this command does is it appends our element I to the back of lst. Okay. Now when we print lst, it contains all the even numbers up to but not including 20. So now we have some elements in our list. You saw the append command, so if I wanted to include 20, lst.append 20 includes it in our list. Now we'll show you how indexing works. So as in most languages, the index elements of a list and other data structures start at 0 and go up to but not including the size of the list. So to get the first element, we'll do lst 0. And that's 0, as you can see here. To get the second, lst 1, that's 2. Now to get the last, we can do something like this. So the len command takes in a data structure like a list or a tuple or a dictionary and outputs the number of elements in it. Okay, so if we do len of list, we get 11 because there are 11 objects in list. Now, if we were to try and use this as our index, we'd get an error because the numbering starts at 0, and when you're counting the number of elements, you typically start at 1. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? If we want to get the last element, we could do list bracket len of list minus 1, which will give us the last index, which is 20. The other useful feature that Python has is that you can use negative numbers to start traversing from the back. So lst of -1 will give us the last element, lst of -2 will give us the second to last element. I guess a good way to kind of think about how the negative numbers work is you take the negative number and you add it to the len of list, right? So here we have LST of -1 is 20. To get the last element, we could also do LST of len of LST -1, and it's the same thing. So that's a good way to kind of think about how the negative indexes work. But if we do LST of minus len of LST, we'll get the first element. So that's a very useful way to view lists. Like I said, lists are iterable, so we can do something like for I in LST, print I plus 1, and it'll add 1 to every element in the list, giving us all the odd numbers up to 21. Similar to a list is the tuple. So we can define a tuple with either 2 parentheses with a comma in them. It can't be empty, so let's just make it with a 1. So that's a tuple. We could also just do the tuple command, and that'll give us our empty tuple. So tuples are kind of like lists in that they can store many elements. So like we could create a tuple of 1, 2, 3. Oops, sorry. This has to take an iterable. So if we input a list, that'll convert it to a tuple. We could also just have defined it like that. So let's create one. We'll call it tup. And we'll make that 1, 2, 3, 4, 5. So tup is our tuple. Now, the one difference between lists and tuples that's pretty important is that tuples are immutable. So you can do similar list commands, like the indexing works the same, and everything like that, but you can't add to it. So if we try to do tup.append 6, there is no append method. You can't add to it. You can't also try and do something like, you can't assign objects in tuples because they're immutable by nature. So we'll see where tuples come in handy later. And when you return multiple values in a function, the default structure is a tuple. So we'll see that in a second. A third very useful data structure is the dictionary. So to define a dictionary, we could either do dict, or we could just two braces like that. Dictionaries are defined as follows. So you have, let's make 2 just to show you how you can make 2 dictionaries. So we can do dict of, we'll do it this way first actually. Dict 1 equals, open our curly braces, and now dictionaries are a set of key-valued pairs. So let's just say we want to have a key for score. So you have the key. It could be of any type. It could be an object, a string, a tuple, an integer, whatever you want. And we'll set the score to 5. Players 8. Now if we want to see dict 1, it prints out every element in it. So if we want to get element 0, it won't work because there is no key for 0. But if we want to get the element for score, we get 5. If you haven't noticed yet, strings in Python can either be defined with a single quote or a double quote. So there you go.